Good afternoon. Thanks for having me. Right out of the gate, I really just have to say this, that my heart absolutely goes out to everyone who's been impacted by these fires, whether or not it was direct or just us with our empathetic hearts feeling it. Never did I imagine that the nightmare we experienced in October 2017 would be surpassed. So it's, quite visceral, the reaction that I'm having even being here physically in Chico. I personally lost my in-laws to the fire. They were trying to escape their home but couldn't. So I had this personal tragedy and experience with the Tubbs fire. But on the other hand, I had this awesome experience watching nature recover and finding my own healing in that and helping the public come and understand how nature is resilient and how it can help us be resilient. And it just brings the work that I do, it means that much more. So with that, I'd like to share with you how Pepperwood is responding to the Tubbs fire. To give you a sense of who we are, Pepperwood is a place where researchers and the community come together to really address our most pressing environmental challenges. And we are a nonprofit organization that privately owns a 3,200-acre nature preserve, which we consider our living laboratory. We're out there exploring it. We're out there educating the public about it. And we have a really great facility. The Dwight Center for Conservation Science has classrooms. We have a small herbarium. So I'm going to seek you out, Jason Alexander, and become a member of the California Consortium of Herbaria. So we're a great facility and place to come convene, talk about science, and learn about nature. We have been operating as a Sentinel site for about 10 years now, maybe even longer. Sentinel site meaning we're monitoring, we're looking at what's happening on the landscape. We have sensor networks in place. We're out there looking at breeding birds, wildlife cameras throughout the preserve. We're monitoring stream flows. We're looking at grasslands, chaparral, forests, you name it, phenology. And I should mention, does that work? Yeah. So we are located just northeast of Santa Rosa here in the heart of the Mayacamas mountain range. So we're intercoastal mountain ranges. I have always been an advocate of monitoring. Even if you don't have a distinct hypothesis, get sensors out there. We are in a time of change. And thank goodness we had our sensors out there, because the 8 years I've been working at Pepperwood, we have gone through a historic drought, a historic wet year, and now a historic fire. And we have a baseline data set. So we have a great opportunity to really learn what's taking place through change. This is very trigger happy. This is an image of the Dwight Center here, kind of in the center. Towards the top of the photo in the background is Mount St. Helena. At the base of that mountain is where the Tubbs fire initiated. And that initial firestorm, the fire came towards us in this photo and went to Santa Rosa. I show this image because I really like how it illustrates the complex topography that's out here, as well as the mosaic of vegetation communities and the mosaics of fire impact. So not everywhere burned hot and severe. You can see at the top of what we call Grouse Hill, there's a mature Douglas fir forest that has been killed by the Tubbs fire, but just to the north we have refugia for wildlife, for plants, for seed propagules. This image to the right in black is the Tubbs fire footprint, and in red is the previous fire, the Hanley fire from 1964, almost identical. This is a very well-known fire corridor. It has burned regularly for a long time. So it's not a question of if it will burn, it's a matter of when, and will we be prepared as people living in this wildland-urban interface to deal with future fires, and potentially more hot fires and more frequent fires. The difference between Hanley fire and Tubbs is that the Hanley fire took days to reach Santa Rosa, whereas the Tubbs fire took a matter of hours. Hanley fire didn't have any loss of life, only a few hundred structures burned, but the Tubbs fire burned thousands of homes and dozens of people perished. So, and that's going to become more so as populations go out into these beautiful wildland-urban interfaces and are rebuilding, unfortunately, wooden structures again. It's the homes that we're burning. That really, it's a tragic loss. This outline in green here is Pepperwood's boundary, and in red is the Tubbs fire. So the majority of the preserve did burn. And the first initial firestorm really just burnt this front section of the preserve. And then it took another 3 days to go through the rest of the preserve. So that's what we actually want. We want low surface level fires burning our forests and woodlands slowly, getting rid of that litter and thatch buildup. This is from one of our wildlife cameras right by the Dwight Center in Serpentine Chaparral. And at that location, the fire came in about 2 a.m. and within a matter of moments was engulfed. And 20 minutes later, there's still embers. 45 minutes later, still embers blowing in those extreme Diablo winds. Compare that to the next evening in a forest, that nice surface level fire that we want to see. Took about 10 minutes to reach the camera. We did lose residences. Everyone got out alive, thank goodness. We also lost our historic barn here, which housed all of our research equipment and vehicles. And you can imagine all of our sensor networks out there were in various levels of damage. So the immediate hours after the fire were all about, is everyone safe, and infrastructure. So safety and infrastructure became priorities. I was fortunate enough to get back to the preserve just a couple weeks after the fire because I knew that the grasslands were going to be coming back first, and so I wanted to get out there to my grassland transects and see how well they burned, and it was quite eerie. It was a moonscape, something I've never seen before. And I think the most eerie part was that it was silent. No rustling grasses, no birds, no lizards scurrying about, and there was almost this sense of anticipation in the air. For weeks, we were just kind of on edge. Dead, dying trees, maybe trees with, sick trees with pathogens left ashen ghosts on the forest floor. We had some areas burn in high severity, some areas that looked great. And the first signs of wildlife included gophers, so gopher mounds, as they're going for their underground storage caches, they were churning the soils right away. In places that were burnt to a crisp, we saw pyronema, which is a fire-following fungus. So these, chaparral areas that were just black, all of a sudden became bright orange. It was really exciting to see. And then the grasses came. Invasive annual grasses, but still, it's green. So there's a sense of, relief as soon as we started seeing green. 4 to 6 weeks after the fire, we saw completely leaf-scorched oak trees send out new shoots. Trees that looked top-killed. Stump sprouts began coming. This is a black oak. I love this photo. We get a lot of questions, what is this going to look like in 50 years? Well, those blackened trunks are what it's going to look like. We're going to have these young stump sprouts from the Tubbs fire grow into trees, a ring of trees. And so those are most likely from the Hanley fire. Who knows how old this individual is? You cannot count tree rings on this. And how many times has it experienced this same kind of growth pattern? I don't know. It's really neat to see and think about. About 8 weeks, 10 weeks after the chaparral started coming up, chamise, toyon, redwood stump sprouts, epicormic growth on the trunks of redwoods. There's fire-following moss in places that burnt really hot that came up. And then our lovely geophytes were some of the first green to see, and in numbers that I've never seen before. Photosynthesis. In spring, our grasslands were green. A lot of productivity. You get rid of that dry litter, the thatch layer, and those plants go haywire. Wildflower displays. This is cream cups and California poppy, lupin. Again, duck camas and soaproot. These are common plants that you see scattered about, but after a fire, they definitely take advantage. There's redwood or chaparral lily, a rare plant. Diogenes lanterns. It was just spectacular. So as Heath and Brian mentioned, we hired some botanists in spring to do surveys for us, and they did a really great job covering the chaparral. We've documented 12 new species to the preserve, 8 of which were post-fire endemics. Endemics in this case meaning these plants require fire for their life cycle, and you'll find them 1 to 2 years after a fire. And then 2 new specialists, which also require fire for their life cycle, but you'll see them a little bit further out, so 1 to 2 years, maybe further into early successional stages. And then 2 new opportunists, which are those plants that we see commonly, but maybe not in the numbers that we saw after the fire. So the endemics were Brewer's Red Maids, Harry's Suncup, Venus Looking Glass, California Mustard, Catchfly and Rock Rose, Torrey's Cryptantha, Whispering Bells. This is from Sugarloaf, because our patch was tiny, but I'm proud of it. Post-fire specialists include Griffin's Bellflower, Blue Toadflax, and then opportunists that are new to the preserve are Mock Parsley and Skullcap. In with the good, in with the bad. So stinkwort is a new invader to our region. You often find it, gravelly roadways, highways, riverbeds. We had a handful of populations at the preserve we were actively managing. And then after the fire, it was everywhere, uniformly distributed and sprinkled throughout our forest, deep places that I've never seen it. So it is a late bloomer, kind of like a tarweed, and it was in seed in October. So with those high winds, with the heat and the smoke rising, and then the ash depositing, I believe that's how it is distributed throughout the region. So this is a plant we're going to be watching. It'll be interesting to see if it takes root, or if it gets shaded out and can't now compete as succession takes place. There's also broom, which I'm not surprised, but it's just daunting. This is from my commute to work every day. It's a woodland that's been top killed. All that greenery you see are millions of broom seedlings for miles. So, and private property, people don't know what's coming. I see what's coming. We're going to have shrubland that's fire prone, very woody, lots of dead standing fuels, and they're building houses in this again. So resilience, guys, we got to educate people. In summer, the thistles were intense. The Torulus arvensis, this, what is it called, tall sock destroyer. It was on me, it was on wildlife, it was on our cows. It was pretty miserable. This here is an image of a lesson learned. This is a field break we developed for a prescribed burn we were going to do in October 2017. My thought is that by us agitating the soils and then having a mineral soil line, the fire didn't burn hot, so it didn't kill the weed seeds in this location, and so it became a weed highway. And so now I know if we're going to be doing future prescribed burning, we need to be managing our field breaks for weeds. So just quick, going over some of the research we're doing in our grasslands and forests. I'm not going to do chaparral because Brian and Heath took care of that for me. Very quickly, we have a long-term grassland monitoring project, and one of the things you expect after fire is higher productivity. And we did see an increase in fresh biomass in our grasslands and a nice reduction in thatch. That's what you expect. It was nice to see. This is after the fire. Our monitoring program, we also detected the spring following the fire that there was an elevated level of bare ground. That makes sense. Everything that was there was burned away. But even after the spring season and the spring growth, we still had a lot of bare ground, so we modified our management methods and made our cows basically move faster through the grasslands, leaving more residual dry matter to help prevent erosion. And you can see this, there's an exclosure here that's fenced out. The foreground has been grazed after the fire, and we brought our cows on after May, so like late May, early June. And we left a lot of material behind, but it was productive. Lots of overlapping plant species. It was a fuel source, right? So people were saying, oh, don't bring cows on after a fire, let it rest. No, bring cows on and manage your European grass fuel source. Our forests, I mentioned that right after the fire it was about infrastructure and safety. We have the public coming up here, we do work in our forests. We had to do assessments for hazardous trees. And all of a sudden we're dealing with a landscape that is going to come down and is still coming down. We had 16 linear miles of hazardous tree situations along roads and trails, 400 acres of which we needed to remove those dead snags. We are leaving everything else and letting nature run its course. Here's that road I showed earlier of high severity. This is it 1 year later. So these plants are adapted to fire. And one of the things that we had was right after the fire, people contacting us, what do I plant? everything's burnt. And I kept saying, nothing, don't do anything, just focus on erosion control, focus on other issues, wait for a while to see if you even want to plant. And in this roadway, we have ceanothus and chamise coming up where it hadn't been before. So again, the seeds are just waiting for these opportunities. This is the area we had slated for prescribed burning that October. We have, it's the only place on the preserve where we have pre-fire fuels data. Again, thank goodness for monitoring. And the plots that I am monitoring are in those pink circles there. There's a story on the coastal mountain range. If you don't have fire, you have encroachment by Douglas fir into your diverse oak woodlands, hardwood forests. And so we are actively managing for Douglas fir incursion. We go in with chainsaw crews, cut it down, and then do what's called lop and scatter. Just cut it into smaller pieces, spread it around, hoping that it'll come in contact with soil microbes and start that digestion process. Well, it takes a long time for that stuff to decay. And this is one of our plots in the top left. You can see there's a lot of material on the forest floor years after we've treated it, and the fire consumed about 80 to 90% of it. The leaves you see there are from after the fire. And then we do have some recovery in our herbaceous layer here. There's a lot more light in the forest here, which it has a neat story. Large trees came down. Here's a large black oak, so we did have some larger fuels maintained. Dead standing trees were completely consumed. You can see a hazardous tree here just kind of hanging out on the side. And then young juveniles were completely consumed, but the following spring are now coming back. I should mention that David Ackerley from UC Berkeley has 54 long-term monitoring plots on the preserve, so we are literally monitoring thousands of trees. It's quite exciting. The herbaceous understory in these plots, we saw a bump in native and exotic fir cover indicated by the blue bars, and we found 23 new species after the Tubbs fire, many of which were native clovers, nitrogen-fixing clovers. We're monitoring the seedlings, and similar to what Cajun was saying, we saw an increase in bigleaf maple, so perhaps fire is beneficial to maple. Initially, we saw mostly bay, Douglas fir, and coast live oak, over 350 coast live oak seedlings, and then not even a dozen directly after the fire, so it'll be interesting to see how these plant species are going to be regenerating and what the demographics are moving forward. We did find manzanita appear in our plots where it wasn't before, so whether those seeds were brought in by wildlife, whether they were there before it became a forest, who knows, but it's quite exciting to watch. And then these poor oaks that are completely top-killed and they're struggling, they're putting out these new shoots trying to feed themselves, and along comes deer, just completely browsing them, and a powdery mildew everywhere. And apparently this powdery mildew is very common after fires. There hasn't been any research done on whether it is activated, like if the spores are released following fire, but that might be an avenue of some interesting new research. This circle area is where I was describing the prescribed burn area. When we were out there doing our monitoring, we just realized that location and the fire behavior there really didn't represent the Douglas fir management we do across the preserve, nor the plant communities and the fire effects across the preserve. So we established a post-fire fuels management assessment where we put in around 50 plots, both within and outside our treatment areas, to see if we can see any effect that our fuels management may have either on fire behavior or on forest recovery. So it'll be quite interesting to see what we find moving forward. There were areas that burned really hot, like this black oak forest here, and we think that's because of all the slash buildup. So we are actively going to be managing the slash we produce through our Doug fir removal activities, whether it's pile burning or prescribed burning or even chipping in areas. But we're dealing with a lot of dead standing fuel now. Moving forward, we have a lot, it's not just us doing research at Pepperwood, there's a lot of people tapping into our resources. We are living laboratory open to you guys if you want to have a study site post-fire. We just installed a couple of infrared wildfire monitoring cameras through the University of Nevada, Reno for an early fire detection network. We have rain gauges from Sonoma Water looking at flood detection network. We are doing soil infiltration work with the USGS. We have teen interns looking at redwood ecology in response to fire. We're going to continue working with our Native Advisory Council and CAL FIRE to do more prescribed burning. And one of the strengths of Pepperwood is really bringing scientists together to provide products for the public so that we can get work done on the ground. And so we held in May 2018, we held a symposium called Living with Fire, and those proceedings are available online for you to look at. And we're also, right now I think we're in the works with Mark Tuckman and Sonoma RCD and the Sonoma County Forest Working Group to hopefully get funding to do a project where we can refine our fuels models and maps and come up with a strategic regional fuels management program, and then connect those landowners with resources and hopefully funding to get that work done. Because it's not just about resilient plant communities, and especially here, it's about resilient communities, people working together, working with their natural habitats so we can hopefully buffer the next wildfire. So with that, thank you.